everyone, welcome back to another video. So last video we did polar coordinates, just what the definition is, and today we're going to start doing some calculus with polar coordinates. Specifically, we're only going to be doing arc lengths, and I think we might do volumes and surface area. Sorry, yes, we've only done surface area. No, we've only done arc length. But I think in later videos we're going to go through volume and that kind of stuff. So not yet, only surface area right now. Sorry, only arc length right now. Okay, so first of all, we're going to think about how we convert between kind of polar coordinates and then like the Cartesian form, and we're just going to look through. And it'll flow kind of logically. Okay, so the Cartesian parametric, Cartesian parametric is kind of like x equals ft, y equals yt. So it basically, sorry, y equals gt. So x equals something, y equals something. That is kind of the philosophy that we want to approach polar coordinates with. So we can think of polar coordinates as just r to the f theta. So for example, if a polar coordinate was r equals, let's say, 2 theta, then for the point pi, right? You know how polar coordinates is like this. For the point pi, the r would be 2 pi. So that's the idea. R, just like how with normal equations, polar form is r of the f theta, okay? And let's try to think about an example. So if we think about x equals a, that's the same thing as saying every point on the graph has to be at x equals a, but it can be any y, right? And so we get this line here, and that's at a. Same for y equals b, right? Y equals b, every point along, like it has to be b equals y, but every point here can be any x it wants, like that. So that's the same idea with polar coordinates. If we said r is equal to some kind of thing, r equals something, okay, well that just means that for every angle, right, r, if we say r equals r0, which is a constant, that's the same thing as saying f of theta is equal to r0, okay? And so what it means is every point's going to be, every point at any angle, right, at angle equal to, let's say angle is like 0.1 theta, it's going to be r0. At angle 10, it's going to be r0. So it's that idea. And any kind of form like that creates a circle like this. Okay. And same thing if we lock theta, right? So if theta is equal to theta this, so basically a constant theta, then what we have is we just have this. So it's just an idea of kind of how we're going to explore it. And if you can intuitively understand this, and you can intuitively understand these, then we're good to go to the next step. Okay, so how do we convert between r equals f theta and to Cartesian? Okay, so we're going to do r equals f theta. Oh, sorry. What was it again? R equals 2 cos theta. So f theta is equal to 2 cos theta. Okay, how are we going to do this? Well, if you remember the triangle, r, x, y, and theta, we know that x is going to be equal to, and I suggest starting off with x every time, or that's how it's been seeming, like we always start with x, or y, we can do y if it's convenient, but x is equal to r cos theta, right? And so what we can say is r is equal to 2 cos theta. So if let's kind of find what we want x in terms of r, and we're going to do another transformation later, but you're going to see why. So I'm going to say that r over 2 is equal to cos theta. And so we see cos theta and we see cos theta. Well, we can substitute that in. What we get is equal to x equals r times r over 2, which is equal to r squared over 2. Okay, that also means that r squared is equal to 2x. And if you remember the equation, think about this, right? Pythagoras, r squared is equal to y squared plus x squared. If r squared is equal to 2x, therefore 2x is then equal to y squared plus x squared. Because y squared here, we can sub that right into there, and we just flip this side. So 2x 2x equals y squared plus x squared. And you just simplify this, you just say 0 equals y squared plus x squared minus 2x. This is going to be plus x, or how are we going to do this? This is plus x out of x minus 2. something. I don't remember what it is, but this ends up to be, let me just go find it. 2x equals this, and then we do some weird transformation, but what we end up with is x minus 1 plus y squared. X minus 1 squared plus y squared is equal to 2. I don't know how we get there. I could have sworn the teacher did this in class, but I don't know how we got there. What I can imagine is, I actually have no idea. I have no idea at all. But it gets there. It gets there. And what it looks like is just a circle, but at the point 1, like this. And I just didn't know, and the radius is 2. Oh, then that should be 2, shouldn't it? I actually don't remember. I think it was 1 and 1. No, it was 1 and 2. I don't know. I actually don't remember. But all that matters is that that was a circle, but that's how you convert it. And I'm not good with the algebra stuff, but let's keep going. Okay, so we're gonna convert r equals 2 sec theta into Cartesian. So this one, we're gonna convert this one. Okay, well we first say that r, well that's equal to 2 over cos theta. Okay, then x is equal to r times cos theta. We know that from before, right? The triangle, and then r multiplied by well cos theta is just going to be 2 divided by r, right, to be equal to cos theta, so that's that, and then x equals 2. So it's just a straight line like this. If we wanted to convert r equals minus 3 cosec theta, then cosec, because it's 1 over sine x, or 1 over sine theta, then we know that y is equal to r sine theta, just from the triangle, right? Y, x, r. So if theta is here, we know that x is going to be r cos theta, and y is going to be r sine theta. So r equals sine theta, and then we just put r into here because it's r equals there, so r equals minus 3 1 over sine theta. So it's minus 3 1 over sine theta multiplied by sine theta. The sine thetas cancel out. It's just y equals minus 3. And this was converting x equals x, y equals x squared into polar form. And so how do we do this? Well, what we do is we try to use y equals x squared, and we try to use the idea before. So if the triangle here, then x is equal to r cos theta, and y is equal to r sine theta. So if we have y here, it's just going to be sine theta, r sine theta is equal to the square of this, so it's going to be r squared cos squared theta, right? And then we cancel this out, then r is going to be equal to sine theta over cos theta. Okay. Actually, that's it. Yeah, I believe that is the function. No, that's my bad. Cos squared theta. And what this is, it's going to be tan theta multiplied by sec theta. Okay, and why do we use polar coordinates and not Cartesians? You know, like, why are we kind of doing this funky stuff and not, like, for example, just doing it in x and y? Well, that's because sometimes the polar will be more simple. The integration will be more simple in polar form. Like, for example, right? Like, instead of doing, or I suppose we'll look at the next example, because I was going to say tan theta sec theta. If you were to integrate that, that would just become sec theta. And that's the idea, is that sometimes there's going to be these combinations where it makes it simpler. So let's look at an example. So let's use r equals theta, right? It looks simple, but it actually looks really crazy. So if you imagine this, at theta equals 0, r is equal to 0. So we go 0, which is this way, but then it goes nowhere because it's at 0. Okay, at r equals, let's say pi over 2, 45 degrees, right? R is going to be pi over 2. So let's say we go at this is 45 degrees, and we get this point right here, which is pi over 2 log. Okay, now this is not pi over 2, this is pi over 4, sorry. And then at pi over 2 is longer, and it's up here, it's a 90-degree angle, remember, it's up here. And as you go out and out, and out and out and out, it goes even bigger. So it goes in like this kind of like large loop, and it basically becomes a spiral. That's a very complicated equation. So we first sketch it, and now let's try to find the let's try to find it in let's try to find it in Cartesian form. And you might have saw a sneak peek there, but let's go through the thinking processes. So r, well, if you remember, r squared is equal to x squared plus y squared, right? Just from the triangle Pythagoras. And therefore, we know that r by itself is the square root of x squared plus y squared. And so we can say square root of x squared plus y squared is equal to, and then what's theta? Well, theta, if we think about it, is just cos, actually theta is, if you think about it, y and x, theta is just the arctan of y over x. And therefore we can say x squared plus y squared is equal to the arctan of y over x. And I believe there was another step to it. And if you tan both sides, just to kind of get y over x by itself, then it would be tan of x squared plus y squared is equal to tan of this. It would give you y over x. So this is clearly a very complicated kind of equation. So that's the idea. Yeah. So let's keep on going. So I think that was enough examples about going from polar to Cartesian. So now let's look at the arc length of a polar kind of function, right? So again, we have something, let's say that we had a alpha, we had something angle alpha. At angle alpha, it was this point, and then at angle beta, it was this point. And so if we connect it, it creates a function, right? R equals f theta from theta equals from a to beta. If we think about it, what we can say is x equals r cos theta and y equals r sine theta. Well, what does that mean? Well, that's simply f theta, because r equals f theta, right? So we just replace r with f theta and then multiply by cos theta. F theta times cos theta, f theta times sine theta. And let's imagine if we said x equals f of t times cos t and y equals f of t times sine t. There's no difference between this and a parametric function, right? So this is, instead of just doing in t, x is a function of t, no, now x is a function of theta. So what we can do is we can use the same parametric arc length formula, which is dx over d theta squared plus dy over d theta squared. And what you get is this stuff, right? dx equals this thing. That's the product rule from before. Product rule because f theta multiplied by cos theta and all those kind of things. And once you do all the calculations, what you end up is at dx over this is supposed to be theta, dx over d theta squared plus dy over d theta squared is actually equal to f dash theta squared plus f theta squared. In other cases, we can say that a better way to say this is if I put the f theta in the front, dx over d theta plus dy over d theta within the square root, right? Well, that's actually equal to r squared plus dr over d theta squared. That's it. That's the idea. And now we use the new arc length formula, which is just that. That's the square root of r squared plus dr over d theta squared. So let's try to go through a few examples. So for example, if you imagine r equals theta, right? We had that spiral from before. But in this case, it only goes to like pi, right? Which is here, because that's the full angle of pi. And it goes to this point here. Okay, so we put arc length is just equal to this, and you do r equals theta, and then you dr over d theta is equal to 1. So it's just this. 1 squared is 1, so technically it's 1 squared, but then 1 squared is 1. Do all this stuff out. You can do integration, all those kind of things, and it comes out like this. One thing that I did not know, because this is how I usually do it, right? I do and I change the limits. So you do, if you see this, we use trig substitution, we do all this kind of stuff. Sec cube theta turns out to be this. I change the limits to be whatever it is, and then I put it in like this. So sec arctan pi, for example. But I didn't know you can do this. But you can keep it at that. You can come back here and you can do 1/2 sec u tan u, and then just use your theta. Theta equals tan u, right? So you can just put theta back into tan u, and if you look at it, 1 plus tan squared u is just sec squared u, and we have sec here. So therefore, sec u is equal to the square root of 1 plus tan squared u, and tan is theta, so it's just square root of 1 plus theta squared. And so what we end up is this, from 0 to pi. It's really cool. Another caveat is when we try to find like the modulus because it was the square root of sec squared t, and then we took it out. So it has to be mod of sec t. And we have to think about if sec t is from 0 to pi. So simple as that, you just remember that this function, where is it? So if you remember, when we substitute it like this, it's actually not 0 to pi, but we use theta equals tan t. And what happens here is we said that if it was 0 to pi from before, then we say 0 is equal to tan t. And so t would be equal to arc tan 0. So that would be 0 here. That's fine. Arc tan of 0, 0. That's why. So t would be equal to 0. But then if we had theta is equal to pi, we have arc there. Theta is equal to pi. Therefore, pi is equal to tan t. And therefore, t would be equal to arc tan of pi. Basically, we're only worried if sec t is going to turn into a negative number or not. And sec t, we're only going to worry if t is going to be kind of like a number that's going to be worryful. It's going to be what's it called? If t is negative, right? Sec cos. Actually, I don't. 0 to pi. In fact, wait, let me check really quick. Right, so I'm not sure here, but I'm going to put my theory forward is that arctan of pi is positive, because if you think about it, the arctan graph looks like this. So the arctan of pi basically says we have a point here that's pi, and let's trace it and find the angle. And this is the angle, and you can see how the angle is going to be positive. So because of that, we can remove the modulus sign. That's kind of my assumption here. I think the teacher said that in class, just wanted to make sure. I'm not really sure, but yeah, you can do that, do the limits, do that. But this is all integration. It's not really arc length. So let's get next to the next example. So we have r equals e theta, right? So we have 0 to pi, okay. And so starting from 0, e to the theta would be e to the 0, which is 1, and theta of 1, we're going in this direction, we go out by 1, so it causes this kind of spiral. So again, we use the same equation, dr over d theta and r, so r squared plus dr over d theta squared. All this kind of stuff, again, it's just integration from here. One special one I want to talk about is we want to go back to this, r equals 2 cos theta. So if you remember from the start of the video, this was kind of a circle with radius 1. Yeah, so with radius 1. And so for this one, basically, we do all those kind of things. We do that. But I got the answer 4 pi, and that's wrong, right? And that's wrong. And the reason why it's wrong is if you work with the equation, what you get is that you start off, so let's take theta equals 0. Theta equals 0, we're going in this direction, right? I'm going to use a different color for this. We're going in this direction, and cos 0 is equal to 1. 2 times 0 is this. So we go in this direction, and it's 2. We look for 2. So this point's 2. So here's 2. Okay. Now, and 2, and this is theta equals 0. Theta equals 0. Okay. For, let's say pi over 4. Pi over 4. Let's think about it. Okay, pi over 4. So cos pi over 4 is this direction, and cos of pi over 4 is root 2 over 2, right? Cos pi over 4 is equal to root 2 over 2, and 2 times root 2 over 2, well, that's just root 2. So what we go is we go in this direction, and we go look for root 2. So it's going to be like somewhere around this point here, right? And then at pi equals 2, so pi equals 2, the cos graph looks like this. At pi equals 2 here, cos is equal to 0. And so we have 2 times 0 is 0. So at 0, pi over 2, we go up this direction, but then we go 0, so it's right here. So what we end up with is a shape that looks like this. Right? I'm going to redraw it right here. So a shape that looks like this, at pi over 2. That's a circle, right? A circle, if it takes pi over 2 to finish a circle, finish half of the circle, then it takes pi to finish a full circle. Therefore, if we were to integrate until 2 pi, what we do is we'd end up doing the circle twice, because each circle is a pi, so if it's 2 pi, it's 2 circles. And therefore, the arc length of this should be 2 pi, because it's 2 pi r, and r is 1, so 2 pi of 1 is 2 pi. And therefore, if you use the formula blindly, you can get bad results like this. So that's just a thing to keep in mind. Yeah, that's the idea. So anyways, that's the end of this video. I'm gonna upload it now. I'm gonna do some other work. Thank you guys so much. Have a good rest of your day.